Hey, so today we're going to be talking about mirrors and how light reflects off of them. So we've talked about the law of reflection before, so we're going to look back at this when we draw our ray diagrams. So again, to remind you about the law of reflection, that means that the angle of incidence, which is this angle here, equals the angle of reflection, which is the angle right there. And we're going to be looking at our incident ray and our reflected rays and how that incident ray hits the mirror and how that reflected ray is reflected back. So we're going to be looking at concave mirrors. There's two types though. There's concave and convex. But for right now, we're just going to look at concave and how light reflects off of them. So before we get started, we're going to be looking at the different parts of a concave mirror. So we have the center of curvature. So that is the C right here. And think of if this were a completed circle. If this mirror right here was a complete circle, this would be the center of that circle. Then we have our vertex. That essentially is going to be right here. That's going to be the center of the concave mirror. We have the focal point, which means that all parallel rays are going to reflect through that focal point. We have the radius of curvature. It's not labeled on here, and you don't really need to know that for what we're about to do. And then the focal length, that's not labeled here as well, and that is not necessary for you to know. The principal axis is what we would really be talking about. When I say P, this line is P. It goes through the C and F. And then we have our object here. So we're always going to be looking at our object. And when I say P, this is the line I'm talking about. There are going to be steps that you need to follow, and these steps do not change. You're going to be following them every time you draw a ray diagram for a concave mirror. So the first step you're going to do is parallel to P. So we just talked about P. It's that straight line. When you're drawing these rays on the ray diagram, you're always going to be drawing the incident ray first, and then you're going to draw the reflective ray. So how did that ray reflect off that mirror? So this incident ray is parallel to P, and I'm going to show you how we draw that to give you a visual. And then once you draw parallel to P, it's going to reflect through F. So you're going to draw a line through F. Our second step is our second incident ray. Our second incident ray would be through F. So we had our first incident ray, which is parallel to P. Our second incident ray is through F. And again, this is going to sound a little confusing because you visually can't see it just yet. But again, I just want you to write down these steps, and these are the steps you're going to be following every time. So the second incident ray is through F, and that's going to reflect parallel to P. And then finally, the third ray that you're going to be drawing is through F back to itself. And we don't always use step 3, and I'll go into that a little bit more when we talk about examples. So make sure you get those steps written down because you will be using those throughout. So here's an example of a ray diagram, and this is a concave mirror. And we're going to be using those steps that we just talked about. When we use our first incident ray, you're always going to be starting at the top of the object. So you're always going to be starting at the top of, it's usually an arrow. So this is your starting point here, the top of that arrow. So from the top of the arrow, you want to draw a line that's parallel to P. And again, P is this line here. So you're going to get a ruler or a straight edge, anything that allows you to draw a straight line, and you're going to draw an incident ray. And it should be parallel to P. Mine's not the best because it's hard to draw on a computer. but your incident ray is going to be dotted. So we drew an incident ray, it's parallel to P, and our next step, that's going to reflect through F. So once we get to the mirror here, we're going to reflect back through F. So we'll draw a straight solid line through F. So our first incident ray was this dotted one starting at the top of the arrow. And then our first reflected ray reflected back through F. So now I'm going to change colors. We're now going to go to our second incident ray. And again, whenever you're drawing an incident ray, you start at the top of the arrow. So this incident ray will start at the top of the arrow, and that's going to go through F. And again, you should be using a ruler to make it nice and straight. And it's going to be dotted because it is a incident ray. And that's going to reflect back parallel to P. So through F, parallel to P is your second step. And you see that these two lines intersected. Whenever your two reflected rays intersect, so your two solid lines intersect, you can stop, and that is where your image is going to be located, and that is what you're going to see in this concave mirror. And that is going to be the top of the arrow is where they connect. So at the top of the image. And so we know that the arrow would look something like that in the concave mirror. So the image is located between C and F. So that is how you would answer that question. Is it real or is it virtual? So anything on this side of the mirror, so essentially anything on the same side as the image, is considered real. Anything that's going to be located behind the mirror, we consider to be virtual. So the image was located on the real side, so we consider that a real image. Is it upright or inverted? Upright means the arrow would look like this in the mirror. Inverted means it would appear upside down. So we drew the tip where they connected, and that arrow is going to look inverted, meaning it's going to look upside down. And then we need to look at the size. So compared to the original size, how did this arrow's size change? And we would say it reduced. So it's going to look smaller in the mirror as well. So that's how you answer those questions, and that is how you draw that incident ray. So our next one here, it's a bit different, but again, you're going to be using the same exact steps. So the first step would be your incident ray starting at the top of this arrow. And again, that will be dotted parallel to P. So your first incident ray, always parallel to P, and you stop when you hit the mirror. Once you hit the mirror, you're going to reflect back. So that first reflected ray is through F. So you're going to draw a straight line through F. And that's a solid line. So our first incident ray, our first reflected ray. Then we're going to go to our second incident ray. Again, we're going to start at the top of the arrow. And that is going to go through F, and that is dotted. Notice that this line would never hit the mirror. So it was never going to reflect. So we can't draw the reflected ray. So this is when we go to our third step. Our third step, we're going to start at the top of the arrow like we always do. And we're going to go through C. So that's the third incident ray. And then back to itself. So essentially just a straight line back to itself. So that should be a straight line. Again, it's not the easiest to draw on a computer. So notice that these two lines would never connect if we continued these. But this line here would continue and meet this line over there. So you would continue and elongate both solid lines until they connected, and they would connect somewhere over there. And again, wherever they connect, that is where the top of the image would be located. So we have our arrow there. That is what the image would look like in this mirror. And it is located behind the mirror. Is it real or is it virtual? Again, anything on the same side as the mirror, so anything over here would be considered real. Anything behind the mirror would be considered virtual. So we consider that a virtual image. Is it upright or inverted? Again, upright means it would be looking the same way it was. Inverted means the arrow would appear upside down. We would consider that upright since that arrow is upright. And looking at the size, this is the arrow that we started with. This is the arrow that we ended with. It would be considered enlarged. So those are the two examples. Now I'm going to have you complete the practice worksheet that I have provided.